Hi everyone! So in this video, we're going to go ahead and talk about multi-step unit conversions using dimensional analysis. Okay, so for some good news for you, the exact same rules apply whether we're doing single step or multi-step dimensional analysis. So we can always go back to our basis and use that to help guide us. The main difference when we're doing multi-step conversions is that we're going to have more than one conversion factor, which means we're going to have some extra vertical bars, and we're going to multiply or divide a few more numbers. But as I said, again, the rules still apply. So if you ever get stuck, just look back in your notes for some extra guidance, and then also make sure that your units are canceling out on the diagonal. Whenever you're in doubt, think about the units and that diagonal, and that will help you figure out where things go. So let's go ahead and try this out with some examples. Okay, so let's go ahead and try out some example problems. If you have 2.5 liters of water, how much will it weigh in kilograms? And we're told that the density of water is 1.0 grams per milliliter. So the first thing I want to go ahead and do is kind of think about this quantity right here. So this is telling me that 1.0 grams, if it's per milliliter, it's per 1 milliliter. So I can say that 1.0 grams is equal to 1 milliliter. And that's going to be a conversion factor that I will use in my problem. Otherwise, let's go ahead and walk through those steps. So the first thing we need to do is underline our given, which in this case is 2.5 liters of water. Then we want to go ahead and circle what we're trying to find. So that is the weight in kilograms. So I have liters, and I know I need to get to kilograms. And along the way, I'm going to need to use this. So I'm going to need to have grams and milliliters. So if I think about all the conversion factors I need, I'm going to need something to relate kilograms and grams. So I know that 1,000 grams is equal to 1 kilogram. And then I know I'm also going to need to relate liters and milliliters. So 1 liter is equal to 1,000 milliliters. Okay, so let's go ahead and set up our factor label table. So remember, we're going to start by drawing that horizontal line. And then we're going to go ahead and put our given into the first box with the unit. So 2.5 liters up top. Now, I need my units to cancel on the diagonal. So if I have liters up top, I know I'm going to have liters down on the bottom. Now, if I look at all of my different conversion factors, only one of them involves liters, and that is this middle one here. So this is the one I'm going to use in my first vertical stack. So I have 1 liter on the bottom. That's that part right there. And then I have 1,000 milliliters is going to go on top. Okay, again, I know liters must go on the bottom because my units need to cancel out. So I've used that conversion factor. Now, if I have milliliters on top, I need to have milliliters on the bottom because I need to go ahead and cancel out that unit. So if I look at my remaining conversion factors, the next one I need to use is this one right here. So 1 milliliter goes on the bottom, and on top of that stack is going to go the other part of my conversion factor, so 1.0 grams. And again, I need my units to cancel. That's why I know I have milliliters on the bottom. And because I only have that one conversion factor that has milliliters in it left, that's the one I'm going to use in that second stack. Okay, just keep on going. If I have grams up top, I need grams on the bottom. So if I look, my final one, I want to get to kilograms. So kilograms is going to go up on top. I'm going to have 1 with my kilogram and 1,000 with my grams on the bottom. So my units are all canceling out except for the one I want to have in my final answer, which is good news. Okay, so if we look at this, we're going to multiply across the top. So 2.5 times 1,000 times 1 times 1. And then we divide by what's on the bottom. So we're going to divide that by 1, and then divide by 1 again, which doesn't change anything, and then divide by 1,000. So essentially those two cancel each other out, and I end up with 2.5 kilograms. Okay, so sometimes this happens with dimensional analysis problems. You set it all up, you do the work, and you end up with the exact same number that you started with. But the key difference here is we have changed the unit. Okay, so we still need to show the work to show how we got that new unit. But that won't happen all the time. So let's go ahead and try out a new example. Okay, if you have 0.6 gallons, how much is that in milliliters? Okay, so if I go ahead and set up my problem first, I'm going to underline what I'm given, which is 0.6 gallons, and I'm going to circle the thing I am being asked to find, so what unit. And if I pause for a second, I want to think about some conversion factors. I'm going to need to get from gallons over to metric something. Well, if I look at the values given in my notes, I don't have gallons that goes to liters. But I do have that 1 gallon is equal to 4 quarts. So that might be helpful. And if I keep looking, I see that I have 1 quart is equal to 0.95 liters. That might be helpful. And then finally, if I want to get liters and milliliters, I know that 1,000 milliliters is equal to 1 liter. Okay, so let's go ahead and set up our factor label table. Remember, the given always goes in the first spot. So I draw my horizontal line, and then I'm going to go ahead and write that given. So 0.06 gallons. Okay, now going on the diagonal, I know I have to have gallons again because I need to cancel out. So if I look at my conversion factors, I'm going to use this first one. So 1 gallon is equal to 4 quarts. Okay, so my gallons cancel out, which is good. Now, if I have quarts up top, I'm going to need quarts on the bottom. So if I look at my other remaining conversion factors, I'm going to use the next one. So 1 quart is equal to 0.95 liters. Okay, and then my quarts cancel out, which is good. I am left with liters. I want to still get to milliliters. So I'm going to put liters on the bottom, and I want to get to milliliters. So my 1,000 goes with the milliliters. That's how my conversion factor is listed. And then 1 goes with the liters. So my liters cancel out. So if we look at this problem, on the bottom, I have straight ones. And dividing by 1 doesn't change anything. So all that I really need to do is multiply across the top. So 0.06 gallons times 4 times 0.95 times 1,000. So if I go ahead and do that, I get 228 milliliters. Okay, but we need to go ahead and think about sig figs as our final step. So if we look here, we have only 1 sig fig because the leading zeros never count. So I need to go ahead and round my answer to just 1 sig fig. So that means I'm going to have about 200 milliliters if I have 0.06 gallons. So thanks for watching, everyone. Please let me know if you have any questions. Otherwise, have a great day. Bye.